This content is brought to you by Mazunder Academy.
Hello everyone. Today we are going to see descriptive statistics in R. In descriptive statistics, first we will see measure of central tendency. In that we will see mean, median and mode. Then we will cover measure of variations. So in that range, variance, standard deviation and coefficient of variation in R. Then we will cover measures of position. In measures of position, we will see z-score, percentile, decile and quartile. And finally, we will see how to draw box plot and how to determine the outliers. So without further delay, let us start the demonstration. As I already mentioned, mean, median, mode, range, variance, standard deviation, coefficient of variation, then z-score, percentile, decile, quartile and box plots. So these are the contents that I will cover today in this lecture. Suppose this is first question. Write a R program that will use CO2 dataset in R and do the following. First task is print concentration data and find the average, that is mean of the concentration data. Second task, print uptake data and find the median of the uptake data. So to do that, first let us view the dataset. So view CO2. Once you type CO2, there are two options. CO2, first one is a data frame and second one is not a data frame. So we will always choose data frame and run it, control enter. Then we will see plant type, treatment, concentration and uptake. So these are the 5 different columns of CO2 dataset. And we are going to use concentration data and uptake data for mean and median. So go back to the code. First of all, we have to attach. As I already mentioned in previous lectures, if we do attach, then we can access the columns directly without using $. So immediately run it. Now number 1 answer, I need to print. So I will just use cat and then give just a text, say concentration data, and where is the data? It is in CONC. If I run, I will see the concentration data available here. So 95, 175, 250. If we go to CO2 dataset, look at here, the first 95, then 175, then 250, then 350. So these all data are same. So the first work, print concentration data over. Now print average or mean of the concentration data. Second task, cat. So we can put average. In short, I am writing AVG. So what will be the average here? The function is mean. Mean is the function that will find out the average, and where is the data? Data is CONC, concentration. So if you run, you will get your average is 435. So this is task 1. And task 2, print uptake data and find the median of the uptake data. To print uptake data, cat say uptake data comma uptake. So if we run, we will see all the uptake data here, 16, 30.4, 34.8. We can check here 16, 30.4, 34.8, 37.2. So these all data. Now second part is we have to find out the median. Again, cat, or other words, you can write m is the variable where you will find the median and store it, and then your median will be stored in a variable m, and now it is time to print. So cat, you can write median is comma the variable where median is stored m. So if I run this to piece of code, Control enter. So you can see median is 28.3. So these are the two tasks in question number 1 and number 2. Next, mode. For mode, I am using another dataset, empty cars. This is also an inbuilt R dataset. And the question here, find the mode of the gear data. Then we will see the range of the MPG data, then variance of displacement data, standard deviation of HP data, coefficient of variation of rate data. So as we are using a new dataset, first work is view, and dataset is empty cars. If you run it, we can see empty cars dataset have MPG, mileage per gallon, cylinder. It is a car information dataset. So MPG, mileage per gallon, then cylinder, 6 cylinder or 4 cylinder or 8 cylinder car, displacement, then horsepower, then rate, then other parameters, gear, carb. Okay, so these all. So some of the columns we are using for different tasks. Before the task, as you know, you have to attach the dataset so that all the columns of the dataset will be available for use. Now, task 1, I mean serial number 3. So we want to find out mode here. To find mode, we don't have direct function. We have a function mode, but this will not give us the mode. It will give the mode of the data. For example, if I show you mode of, say our question is find the mode of the gear data. So if you write gear, mode of the gear data, and if you run it, you can see it is giving us numeric. That means the gear data all are number data. So this mode function is not doing the purpose. There is a function called MFV, most frequent value. This function is available inside a package called modest. So first of all, you have to install that modest, MODEEST, modest. This package you have to install first. So control enter. It will take little time until it is red here. That means it is running in the background. Something is installation going on. We have to wait. So it is now finished. After installation of the package, we have to load it to library. Library, MODEEST, modest, and immediately run it. Now all the functions inside this package is ready for use. Now MFV is one of the function which will find out the most frequent value, and that is the mode. So MFV of, say for example, MOD, mode is the variable, you can keep any name. So MFV of gear data, GEAR. So mode of the gear data will be stored in mode variable and then print it using cat function. You can write mode R MOD. This is just the same variable name. If you write M, then you have to give M here. Let's run this two piece of code. So we can see mode of the data set is 3. If we want to sure that it is really giving us correct answer, then we can use table function over this gear data, and if we run, we can see data 3 is appearing 15 times, 4 appearing 12 times, 5 appearing 5 times. So the data 3 which is appeared 15 number of times will be the mode, because the other two data 4 and 5, they are appearing less number of times as compared to 3. So that is the mode. Next we will go to find range. That is fourth number question, range of MPG data. Range is the function which will evaluate range. And where is my data? MPG. if, say for example, if I store it in a variable r, then we can print it using cat, and we can give range is the data stored in r. So if you run this two piece of code, you will get the range of the data. As we can see in the output, 10.4 is the smallest data in MPG column, 33.9 is the highest data in MPG column. Next, number 5, if we see the question, the variance of the displacement data, DISP. So VAR is the function that will find out the variance, and DISP is the data. If we store this information, this result, in a variable say v, then we can print using cat command. So variance, where is the data stored for the variance is in v. So if we run these two lines of command, we will get the variance of the displacement data. Number 6 question, find the standard deviation of HP data. So to find standard deviation, SD is the function that will find out the standard deviation, and your data is stored in HP. And let us store this result in a variable s, and then we have to print it. So cat, you can write SD is or something, comma, it is stored in s. So now if you run these two lines of code, you will get your standard deviation. Next, number 7, coefficient of variation, CV. So CV we can calculate in two ways. One is using the rule CV equal to SD by mean multiply by 100%. So this is the rule which we have used in theory. We can use the same rule and calculate the CV. So we can write CV equal to, CV is the variable where we are storing the answer for CV, and SD of which data we have mentioned in your question. Find the CV of DRAT. DRAT is one of the column in empty cars. We can see here DRAT is one of the column. So SD, then DRAT by mean of DRAT multiply by 100. So this will calculate and store in CV, and then we need to print. So cat coefficient of variation CV is comma CV. So if we run this two piece of code, then we can see the answer for the CV is 14.86638. The other way is to use the function CV, which is available inside a raster package, RASTER, raster package. So inside raster package we have CV function which will calculate CV directly. I will show that. So install dot packages RAST raster. So we can install this raster package. This is red, means it is working. We have to wait, and once raster package installed, we have to load it into library and we have to run it. So the raster package loaded into the library, and that means all the functions inside raster is available for use, and among them one of the function is CV. So now if I write, say for example, CV1, another variable, and we write the function CV over DRAT. So in that case, CV will be calculated and it will be stored in CV1. And now if I print cat CV is comma CV1. So if I run this two piece of code, we will get the same answer as earlier. So I have shown you both the method. One is using the formula which is used in theory. Another one is the CV function which is available in raster package. we can install the package and then we can use the function cv to find out the coefficient of variation. So these are the questions. It came under measures of variation. Next, we are going to see measure of position or location. So in that we will see z-score, percentile, decile, quartiles, Q1, Q2, Q3, and then finally box plot. And we will see is there any outliers. To do that, I'm going to use fixed data. Earlier in the previous examples, I have used R inbuilt data. By changing different columns or different data set, we found different statistical measures for different data. But now I'm taking a fixed data just to demonstrate you how can we use if the data is fixed and supplied along with the question. For example, this is a question: write a R program that will store the following given data and do the following works, that is find z-score, find percentile, find decile, find quartiles, and draw a box plot and find the outliers, or we can say print the 5-point summary. We will see all of them one by one. So here the first work is you have to store the data. So let's d is the variable where I'm going to store the data, and we can just copy the data if it is on screen, and using C function we can paste it. Let me run it. So we can see d is created here in the list of variables. We can see d is created with the data. So 9, 9, 8, 9, 10, like this, all data stored in the variable d. After storing the data, my first task is find the z-score. For example, find the z-score of 10. 10 is one of the data here. So we want to know what is the position of 10 in this data set. So the rule for z-score is data minus mean whole divided by standard deviation. So we will use the same. First of all, we have to store this 10 in a variable, say x. Then say z is the variable where I am storing the z-score of 10. So the formula will be x minus mean of the data. Data is in d, whole divided by standard deviation of the data, SD of d. So this calculation will store z-score in a variable z, and then finally we have to print. So cat within double quotes you can write z-score is, and where is the z-score stored? In variable z. Now if you run these 3 lines of codes, then you will get your z-score. We can see the z-score is 0.4257896. So z-score over. Next we have percentile. So before starting the demonstration, let me show you what is the concept of percentile. So if we see the theory, percentile score for a data x is the number of values below x plus 0.5 multiply frequency of x divided by total number of values multiplied by 100. So this is the formula for finding the percentile score for a particular data. Or if we want to know in other way, for example, which data corresponds to 50th percentile or which data correspond to 75th percentile, this kind of calculations we can do. So let us go back for the demonstration. Say for example we want to find which data corresponds to 50th percentile. So how can we do this? There is a function called quantile. Q is the variable where quantile is the function, and inside quantile, where is your data? Your data is stored in D, and you can mention prob equal to, in terms of probability, 50th percentile means 50%, that means 0.5. And if you run this, say for example before run, let me write a print statement also. So cat within quotes 50th percentile. What is the data? Where is stored? Percentile value is in Q. So if we run, we can see 50th percentile data is 9. Similarly, I want to know 25th percentile, I want to know 50th percentile and 75th percentile. Say for example, another variable say Q1, in that case quantile, and inside that where is your data? Your data is in D and you need more than one location. So you have to put them in a vector. Remember that prob is not mandatory. If you do not supply prob word, this R will automatically understand the second parameter is the probability. So I want to know 25th percentile, 50th percentile, and I want to know 75th percentile. If I run the same piece of code, I can copy and paste here. So here 25th, 50th and 75th percentile is your Q1 because you have stored in Q1. So now if you run these two lines of code, we can see, so 25th percentile is 8, 50th percentile is 9 and 75th percentile is 10. So this is the way we can find out the percentile. Next idea, along with percentile, another concept is called decile. Let me take you to the theoretical discussion for decile. In statistics, decile are 9 values that divides a set of data stored into 10 equal parts. So the first, second, third, fourth, fifth, second, seventh, eighth and ninth. Deciles represent the first one 10% data, then second one 20% data, 30% data, and so on. Now in the diagram, if we see D1 represent 10% data, already I say D2 represent 20% data. Like this, there are total 9 division of the data into 10 different equal parts of the data, and these are called deciles. So on the name itself, we can see our division percentage 10, 20, 30, 40. So the same function quantile we can use, where the probability will be mentioning all 10%, 20%, 30% up to 90%. So in demonstration, we will follow the same. So we can see DEC, or you can say decile. And what is the function? Quantile is the function. And where is the data? Your data is in D. And probability, here in that case you can see we need 10, 20, 30, 40 like this, right? Serially up to 90. So we can use the sequence function here, and it will start from 0.1, that is 10%. It will go up to 90%, that is 0.9, and the gap will be 10 gap, that is 0.1. In terms of probability, you have to write everything, and then we need to print. So we can print here decile R. Where is your decile stored? DEC. If we run these two lines of code, we can see the decile R. 10% is 5.6, then 8, then 8.9, then 9, then 9, then 9.6, 10, 10.8, 11.4. So this is the data which is at 90%. So 90th percentile data is 11.4 and 10th percentile data is 5.6. Now after decile, we have quartiles and box plot. So let's do quartile. Quartile, basically, if we see the theory behind quartile, quartile divides the data into 4 equal parts. So the first quartile is 25 percentile, second quartile is 50th percentile, and third quartile is 75th percentile. So to find quartile, we can use quantile function, or there is very important function called summary. I will use the function summary. This will give more meaningful result. Say for example, we are going to find quartile. For example, a variable qt, I will call the summary function over the data D. Then finally, if we just print Qt, so run first Qt, then print. You can see here, this summary will give me what is the minimum data, what is first quartile, what is median, what is mean, what is third quartile, what is maximum. These all informations it will give. Now, sometime the question will come like, print only suppose second quartile data or third quartile data. Don't print all, which is not correct. So if we want to print suppose only second quartile data, then how can we print? Q2 is, in short I am writing, in which variable all the data stored, that is Qt is the variable, and inside Qt we can see the second quartile means median. Median is available in third position. We can see here minimum is the first position, first quartile is in the second position, and median, which is Q2 is available in third position. So we will mention 3 here, and if we run we can see Q2 is 9. If we want to find out third quartile, so you can see third quartile is available in the position 1, 2, 3, 4, 5. Third quartile is available in fifth position. So you mention here 5, and this is Q3. So if we run it, we will get the third quartile as 10. Similarly, we can print the first quartile also. Q1 will be in the position second position. So first quartile is 8. We can see here first quartile is 8. So that's all about the quartile. Next, I'm going to cover box plot. As a theory, if we go to box plot, we can see box plot is a graph of data obtained by drawing a box whose vertical sides passes through Q1 and Q3. Vertical line inside the box passing through the median Q2. A horizontal line whisker from the minimum data value to Q1, and a horizontal line whisker from a maximum data value to Q3. And we must be sure that this minimum and maximum after the removal of outliers. So this point will be clear to us once I will demonstrate you in the data where we have some outliers. And box plot will be looking like this as shown in the diagram. There is a box. This black color, dark black color line is the median. So this is Q1, this is Q2, and this is maximum, and this is minimum. And these two, the upper outlier, and this data is the lower outlier. And this information, minimum, then Q1, Q2, Q3, maximum, these 5 informations are called 5-point summary. So let's go to the demonstration. To draw box plot is the function, and where is your data? Your data is in D. So if you just run, we can see a default box plot is appeared here. And if we want to do some coloring, we can give color equal to some color, say blue, and if we run it, it will become blue color. Now I want to store this box plot information, the output of box plot, in a variable, say B, for my future use. If I run it again, we can see B is created and it is a list of 6 values. So let me just see the data inside B. So just write B and run. We can see here inside B, first parameter is stats. So in stats we have 5 informations: minimum, Q1, Q2, Q3, and maximum. So this is your 5-point summary. Remember, this minimum is not the minimum of the total data set. This is the minimum of the box plot minimum. And your data have a minimum value 3, which is an outlier actually. So you can see in out column inside B, 3 is there, which is an outlier. Then there are total 17 data, number of data, and this confidence interval at this moment we don't need. So let us complete the remaining part of the answer. Say we want to print 5-point summary. So how can I do? Cat, inside that we can write 5-point summary. And where is your 5-point summary available? It is available inside B, then dollar stats. So if you run, you will get your 5-point summary. Minimum, first quartile, second quartile, third quartile, maximum of the box. Next, suppose you want to print the outliers. Then same way we can call the cat function and we can write here just outliers. And inside B, out is the location where outliers available. So if I run, I will get the outlier is 3. Now how to remove outliers? Basically it is a vector. So how to delete an item from a vector? Already it is covered in the lecture vectors. So there you can see how can we delete a vector, and that same process we can apply. And there are some other method also which can help you to delete outlier or remove outlier, or maybe if you want to replace the outlier by some other standard way, like some of the statisticians, they prefer to not to delete the outliers, they want to replace the outlier by the average or most neighboring common values, like that. There are different approaches from different statisticians. That is a separate way of handling outliers in a dataset. So that's all. Thank you so much.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.